Hello, this is Jeremy James, plant physiologist from the Eastern Oregon Agricultural Research Center, here to present an Ag Minute. A substantial amount of money is spent each year in attempts to revegetate vast areas of rangeland in the Great Basin, damaged by fire, weed invasion, or other disturbances. Unfortunately, failure rates of revegetation projects are very high. Developing methods that improve restoration procedures has been a central goal of rangeland scientists for decades. However, most restoration research is focused on understanding how different farming practices, such as seedbed preparation, herbicide application, and seeding rates influence revegetation success. Although these farming practices have been widely tested, research has shown that even when the best farming techniques are followed, restoration efforts still often fail. Surprisingly, very little is known about how variable weather patterns contribute to these failures, even though anyone that has farmed knows that such variation can greatly damage or wipe out a crop. This week I will be describing some experiments we are doing at the Research Center that test the idea that variable weather patterns are a major determinant of restoration success in the Great Basin and may override the benefits farming practices have on restoration efforts. While we all know that crop year precipitation varies greatly from year to year and can strongly influence plant growth and establishment, at the research station we are testing the idea that the frequency of precipitation also may be an important factor influencing restoration success in the Great Basin. This idea is based on the observation that germinating seeds and seedlings can access water only in the very shallow soil layers compared to the deeply rooted established plants. Deeper soil layers remain moist long after a precipitation event, while the upper soil layers dry out very quickly. This suggests that the frequency of precipitation events in the spring may be as important as total precipitation amounts in influencing revegetation efforts. For example, if spring precipitation is divided between only a few large events, the water may drain deep into the soil, but leave the upper soil layers dry for a long time. This may be good for plants already established with deep roots, but may be detrimental to seeds and seedlings. On the other hand, if the same amount of precipitation in spring is divided over many small, frequent precipitation events, the upper soil layers will stay moist, allowing seeds to germinate and grow roots before summer drought hits. This week we've been talking about how variation in precipitation frequency might be important in determining the success of revegetation projects. Years with more frequent precipitation events can keep upper soil layers moist in spring, minimizing drought experienced by seeds and seedlings and allowing these newly emerged plants to establish deep roots before summer drought hits. In Harney County, like other areas in the Great Basin, the average number of days between rain events in spring can vary greatly among years. For example, in the spring of 1995, rain fell almost every other day. In contrast, there was about 11 days between rain events during the spring of 2002. Based on these differences in rainfall frequency, we might expect revegetation efforts to be more successful in 1995 compared to 2002. While this idea seems easy to test, crop year precipitation also differed between these years. It was about 15 inches in 1995 and about 4.5 inches in 2002. To understand how rainfall frequency influences restoration success, we need to be able to evaluate plant establishment under different precipitation frequencies while keeping the total amount of precipitation the same. This means we can't just compare restoration success over multiple years because both rainfall frequency and amount will vary. Instead, we need to experimentally control precipitation amounts. This week we've been talking about research we're conducting to examine how the frequency of precipitation events might influence revegetation efforts in the Great Basin. One problem we noted is that both crop year precipitation and precipitation frequency tend to rise in tandem. As a result, to conduct our research, we needed to develop some tools that would allow us to alter rainfall frequency on a field plot while keeping total precipitation amounts the same. At the Great Basin Experimental Range, we have constructed fixed location rainout shelters to control the amount and timing of rain over experimental plots. 5 shelters were built with pole and truss construction, each about 100 feet long and 40 feet wide. The shelters were covered with a clear material on top, but the sides were left open. Irrigation pipe and sprinklers were installed under the shelters to allow us to control the amount and frequency of precipitation on these plots. With these shelters, we can conduct revegetation projects using traditional restoration approaches and evaluate how these efforts are impacted by either rainfall frequency or total rainfall amounts. This information should allow practitioners to better understand the spring weather conditions likely to maximize revegetation success. Yesterday, we described how our fixed location rainout shelters allow us to experimentally control the amount and frequency of precipitation on experimental field plots. While these shelters allow us to cover large areas, these structures unavoidably modify some factors that can influence seedling establishment. For example, the roofing material on the shelters can significantly decrease the amount of light reaching seedlings and increase soil temperature. To get around these problems, we are designing a rainout shelter where the roof can be kept open when there is no rain, but can automatically close as soon as it starts to rain. Obviously, this involves some tricky mechanics, so the size of the rainout shelter will be much smaller. The basic idea behind this is that as soon as the rain hits an electronic sensor, a motor will be activated that will close the roof. If the sensor does not detect any more rain after a certain time, the motor will reverse and open the roof. Although scientists are a long way off from being able to accurately predict weather patterns for a given year, our experiments using the fixed and movable rainout shelters will allow range scientists to better understand how variable weather patterns can influence revegetation